So yes, hello everyone, it's me Abhay, and today I will explain the question robot collisions, and I will try to explain this in perfect easy way because this question is contains huge amount of implementation and data structure has been used, and the tags are like data structure, greedy, implementation, sorting. Yeah, it will include everyone. And yes, without wasting time, let's move on to the question. What the question is saying? We are given n robots placed on the x-axis. Okay, there are two walls at 0 and m. I have drawn. I will explain the first test case, and I have drawn that in like here. So I will take the reference side by side. So what it is saying, like हमें n robots given है और सारे x axis के लोग पड़े हुए हैं. Yes, we have the x axis and सारे x axis के लोग पड़े हुए हैं. तो हमें रेंज गिवन है 0 से लेकर m तक की. ओके, 0 से लेकर m तक की एक रेंज गिवन है, उसके अंदर ही सारे n रोबोट्स पड़े हैं. उसने क्या बोला है कि सारे रोबोट्स ये क्या मूव कर सकते हैं, या फिर जैसे ये रोबोट है तो वो लेफ्ट मूव राइट मूव कर सकता है या फिर वो लेफ्ट मूव कर सकता है. ओके, और जब भी कोई रोबोट, जैसे ये रोबोट है, वो लेफ्ट मूव किया और वो 0 से 0 पे आ गया तो वो अपनी डायरेक्शन चेंज कर लेगा, अब वो राइट मूव करेगा. ओके, या अब उसने क्या बोला कि अब अगर कोई रोबोट कोलाइड करता है, लेट्स सपोज कि लेट्स सपोज that this robot moves here and this robot moves here. At this point, these both will collide and they both will destroy it. And how much time they survive is 1. Because there is also given like the speed of each robot is 1 unit per second. If they move 1 unit, he moved 1 unit, and at that and this moment they destroyed. How many seconds they survive? This is 1. So we have to report the time of each robot and how much time did he survive. Like for one robot it will survive 1, and for second robot it will survive 1, because after 1 second they both will be destroyed at x equal to 2, right? And if one robot is unable to destroy it, like we have no robots, we have 0 robots and we have only one robot and it is moving like only one robot, so no more robots will be present to destroy it, and it will never be killed and never be exploded, right? So in this case we will print -1. Okay, so now how can we implement this logic, right? The question is a bit clear. We are given the first n, how many robots are there, and m, range from 0 to m. Next line we contains n robots, like from 1 we are given, like I have drawn here, we are given the robots 1, 2, 3, 4, 9, 10 and 11, and their directions are this one. Initially they are directed to move in these directions, like to our right, left and all right. This will move right, this will move right, this will move right, left, this will move left, and these three will move right. Okay, so what we have to do now, we have to calculate the how much time they survive. Okay, here we can see like at time equal to 1, this robot will move at this location, 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 this will add this, and this add this, and this one at this at 10 location, 9 at 10. Okay, here you can see at time equal to 1, these both will be collided and destroyed. They survive at time equal at time 1 till time 1. At time 1 you can see here these both collided and they will be destroyed. They survive time 1. Here no collisions found. Okay, at time equal to 2, this one will rotate and move, come here back, this will continue moving here, and this will move here. Now you can see here the collision occur. It survived, and now these both will be destroyed. Survived 2 seconds, and no one is present to destroy 10 because all are destroyed, and this will survive the infinite time. So here we will print -1, right? Now we get how it is going on, how the process is going on. Now we have to implement it. For the implementation we need any logic, like how can we do this like infinitely, how long will it go. Okay, so here you can notice one thing. The thing to be noticed is the uh, the one which is going, like if I say the 2 is going towards the right and 10 is going towards the left. Will they collide? I can say yes by getting their index value only, because if they are even, if they are present at the even position and this is also present at the even position, and they will definitely collide, no matter how, no matter the m is present. Okay, let me prove this. Like here, 1 2 3 4 5 6 7 8. Let's move on to this, like 1 2 3 4 5 6 7 8. At 8 seconds they both will be collided and destroyed. Okay, if I check for to this one, like this will travel, I guess two more, like 1 2 more, and this will be get destroyed over here and there only, but they will definitely get destroyed. And the position of the odd places, they will get destroyed by the odd ones only. Okay, so here the question becomes, we have to check for the even and odds, right, only. I will, like, here let me draw the, because I will explain the first test case and the third test case, I guess, because these both will contain all the possible cases. So here the even ones are 2, 4 and 10. Here the odd ones are 1, 3, 9 and 11. So here you can see, and here it is like going the axis. 2 cancel with 4 and 10 is infinite because no one is present, like they will get destroyed and no one is present to kill this one. 1 is cancelled with 3 and 10, 11, 9 is cancelled with 11. Uh, Here this can also be proved, right? Okay. Now we have to go on and implement this. So how? Let me go on with the odd ones first. Let me, okay. Let us detail. Let me explain detail. The odd ones. The first one is at 2 at index 2. The second one is at okay, this one is even. 1 at index 1, 3 at index 3, 9 at index 5 and 11 at index 7. I am recording the index because we have to print the location, like answer of with respect to the indexes, like how many times that index value survive. Okay, so here you can see what I will do. I will store the right ones. The okay, I will. I also did one thing. Uh, for left, for the right direction, I denoted 1, and for the left direction, I recorded 0. Okay, so yeah. So these are for the directions only. You can take -1, 2, 3, 4, anything like you want to. How you can denote these directions. So how I can proceed with it, like this will be like, first I will, if the current set is empty, I am using the set data structure. So I will, if a right one enters, like if it is the right one, this is 1. Okay, this is 1, this is 0, this is 1, this is 1. Okay, if the right ones appears, I will push into the stack without comparing anything. Okay, 1 comma 1. And if the left one comes, okay, if the left one comes, now I will check, because left one can cancel the right one, because we need anything to cancel it, right? So if now I will check here, I can check the two cases, if the set is empty or if the set is empty or not. For the empty case, I will take the third test case, which I am going to discuss after this test case, which is this one. These are both left, and here we will discuss the empty set in the left case. So here I am going to discuss node empty case, like here it is node empty. So what I will do, I will pop this one out. Okay, we know that previous one is definitely right because we have inserted the right one. So I will insert, what we will do, this is at the 1 position and 1, then this is a third position, 1 minus 3 abs, and we'll get by 2, and this will the position of the collision, and we will get the answer 1. So means we get the conclusion, the 1 and the third destroyed at time 1. Okay, now we are done with the first two, and this both will be erased. Okay, these both will be the erased. Now we don't have to think about it. So now we have 9, 5. I will push them into the as it is. Now again write. Now I will again push into the stack. Now this now all the odds are clear. Okay. Now I will check if the stack contains more than one elements. Like if the stack contains two or more than two elements, so I can, like, if I am dealing with the only odds and if more than two odds are present, so definitely they will be cancelled out in the pairs. Like if here I have having the pair of 9 and 11. So how can it be cancelled? Like now I know that these pairs which are left after every right after, like, अब हमने सारे लेफ्ट वाले और राइट वाले पेयर चेक कर चुके हैं. वी हैव चेक ऑल द राइट्स एंड लेफ्ट पेयर्स. नाउ वी हैव now after this we have only the pairs which are directed only to one direction, only the left or only to the right. Okay, so these are towards the all are right because we know we are pushing the right ones, and after that we are left only with the right ones. So but how we can judge find the distance between them? Like this is only moving towards right, and this is also moving towards right. Here I get the formula, like this ranges of m. If I subtract m from this and subtract m from this will become this will contain how many time after which time they will collide. Like here the m is 12. I will do 12 minus 9, and what is this 11? I will do 12 minus 11. This will give me 3. This will give me 1, and they sum, like what will do 3 plus 1 by 2, and this will give me 2. This will give me after 2 seconds they both will be destroyed. If I take the case of like this one 5 and 9, these they both are odd and they must be destroyed, right? As I have said in the initial condition, like they will be destroyed. So how they will be destroyed? So they will be destroyed, like if I check for the formula 12 minus 5 plus 12 minus 9, it will give me 7 plus 3 by 2, give me 5. Okay, let me check. 1 2 3 4 5. Okay, 1 2 3 4 and 5. Yes, at this position they both will be collide and destroyed. Yes, this is right. So after this after when I will checking this for the set, if the set of size is more than 2, I will take them out into the pairs. I will take them out into the pairs and uh, find the time, how after what time they will be destroyed, and erase them out till the size of the stack is more than 2, means more than equally 2, means more than 1. Okay, here I handle the odd cases. So here similarly I will, at the same pace I will handle the right case. In this test case, the right case will lead with the one empty condition of 10. Let me go to this. Like here I can go with it. 2 2 is for the right. I insert it in the stack 2 comma 2, and 4 is for the left, and I get the right one and also get the left one. I am setting the set on the left ones. So at the left ones I will get the position of 4 minus 2 by 2, that is 2, and these 4 will be cancelled. And now I will get 10 of the right. I will insert 10 into the set. So after no one left, so now I will check for the 10 whether the set is empty or not. Set contains more than one element. No, set contains only one element, not more than one element. So I will continue with it. No one is present to cancel 10. So this is how this case comes into the picture. So if I take the case of like this case, 1 3 2 range from 0 to 10, and 1 2 3 both are left. So let me erase this. I'm not going to make the full. I will just make the small. Like we are given 1 here, 2 3, and here is the 0, and here is a 10, right? It is going towards the left. It is going towards the left. If we get, now we are processing towards the set, and these both are at the odd positions. If the starting we go to the left and the set is empty, Okay. At the starting, we go to the left and the set is empty. We will insert this value with the negative sign because this will act as a right one. If I like if I will insert this value with the negative one into the set, like I will insert -1 comma 1. After this we will I will add 3, which is also going to our left. When I'm checking this one, I will check whether set is empty. No, set is not empty. So I will pop this out and compare with this 3, and the value will be like 3 plus 1 by 2 because it is doing like minus. So after 1, 2, after 2 seconds, they will be destroyed. So this is the case, like how we can deal with it. And yeah, let's move on to the implementation. This both covers all the cases, and let me show my implementation, how I implement this question. So here I start. Okay, first I take the inputs of n comma m and taken the inputs x. These are the position of the robots. If the robot is odd, I will push them into the odd, and the robot is right, even, so I will push them in the even, like it is sitting on the even x position. Okay, and initially I will make them all -1. I'm not. It is a global. So after each test case, I can't like I have to make all the fill, like, so I am doing it side by side, doing it -1. So after this, I'm taking the n characters, whether it is right or left. For the right one, I'm going with the 1. Whether or the left one, I'm going with the zeros. You can take it anyway because we are not adding or subtracting anything. So yeah, and yes, I have sorted all the odds and even because in the this case you can see these are not given in the serial order which come first, like here 6 even come first and 2 even come first, but after sorting the 2 even come first and then 4 then 6. Then how we can then we will compare and check in, like 2 will be cancelled with the 6 with the least cost. Okay, now I am sorting them out and I am finding them individually for the even case and odd case. I am checking them for the individually. Okay, so this is the find function where I am finding the time, how much time it will take to destroy it, to get destroyed. And here I get the here I pass the full the vector, the odd one and even one, which I have stored the position and the index. Okay, so first, D is the whether it is going left or right. If the D is 0, means it is going left, otherwise it will right. If the current one is right, I will, without thinking anything, I will push into the set. And if another after right, if any left comes, I will check. If the set is empty, as I have said, I will insert them with a negative value and make them right, like I will insert them into set. Otherwise, I will pop the current one and make the time, that is first minus current by 2 and add that time, means index, like index of the current one is the second position and the current of second also is the index because I'm storing the pair like value dot index. So second one contains the index and these both will become the time, and I will erase the current one in the set. So similarly, and this goes for the full odd or even. After this, if I find the set size more than 1, like I have explained here, like if the set contains more than 1 elements, like for the 1 element we will not. If the more than 1 elements, like in the previous case, in the case of first test case, we are here 9 and 11, I guess. So here I am dealing like this. This formula, I am taking the both 2 out at R and L, and both the first position will is the position, and taking time, and second position is the index, and of answer of L dot second and R dot second will be time. So here I have did place the time of that collision. So here at last I will print the answer vector from 1 to n, and initially it is a -1. If anyone get uncollided, so it is initial -1. So we have not to make them catch them at the last. So here I will get the answer printed. So yes, this was my implementation, and yes, it get accepted here. So it was the question C of education round of Codeforces round 109, and question was robot collisions. So yeah, if you like the explanation and if you got it, like how you can solve this, give a like, and if you are new to the channel, give press the subscribe button. And yes, happy coding, and yeah, stay safe and stay healthy. Bye bye. Bye.